Something strange had been happening for the last few hours. After leaving the Mediterranean Sea, the crew aboard the USS Saratoga aircraft carrier spotted an unidentified vessel following them. She had failed to identify herself and had kept radio silence, but the submarine was on Saratoga's tail, seemingly keeping the pace. After waiting long enough, the crew grew afraid of a possible torpedo attack, and the captain then gave the order to steam at full speed. As Saratoga accelerated at some 60 kilometers per hour, the mysterious submarine finally disappeared. Or so they thought. To the crew's dismay, the submarine was no longer at the ship's rear, but at the front, leading the way and moving at a pace of at least 80 kilometers per hour, something quite unprecedented. It was time to call the Pentagon and decide on the next steps if they wanted to survive. In the late 1950s, the Soviet Union began looking for a solution to eliminate American aircraft carrier strike groups. The nation had not fully recovered from World War II and was in no shape to directly engage the U.S. Navy at sea. Following a strategy similar to that of Germany during World War II, the USSR decided to develop state-of-the-art submarines that could get close and personal with the enemy aircraft carriers. But first, the Soviets had to devise a weapon that the submarines could use effectively, as their torpedoes did not reach beyond 4 kilometers. Soviet engineer Vladimir Chalomy then developed a new type of weapon system, creating the powerful P-70 Amethyst, or N-7 Starbright, with an astonishing operational range of 65 kilometers per hour. With this issue solved, the Soviets began working on a unique platform capable of carrying and launching the desired missiles. This unique submarine was codenamed Project 661. Nikolai Isanin from OKB-16 was the mind behind the ambitious program, and development began in 1960. However, it took almost 10 years to complete the one-of-a-kind submarine. Dubbed K-162, the vessel was unlike any other submarine of her time. She became the first submarine with a hull made of titanium alloy, which was anti-corrosion, had low magnetism, and was highly durable. Also, the two-hull structure comprised 9 compartments, but this was only the start of her innovative features. K-162 had more to offer. The Golden Fish. Besides her titanium hull, K-162 innovated using 10 powerful P-70 Amethyst missiles. She was also equipped with an NG-K300 sonar system, a Sigma 661 navigation apparatus, a Radian-1 radar system, and a Nikram friend or foe detection system. Furthermore, she was fitted with 2 light-water nuclear reactors, 2 steam turbines, and 2 shafts to make her a swift attack submarine, able to take down aircraft carriers. This would allow K-162 to reach an impressive top speed of up to 83 kilometers per hour, a feat no submarine could ever do. The only drawback of these tremendous speeds was that noise could reach up to 100 decibels inside the submarine's central station. K-162 had a length of 109 meters, a beam of 6 meters, and a draft of 8 meters, and she displaced over 7,000 tons when submerged and could reach a depth of about 400 meters. She was quickly nicknamed the Golden Fish because of her massive cost of approximately $2 billion. In the fall of 1971, when tensions between the Soviet Union and the United States were still ardent, a strange event occurred in the Atlantic Sea. The United States had given up on Vietnam and had evacuated most of its troops from the South Asian country. Still, the U.S. Navy patrolled the seas to track down any Soviet Navy movements. The Soviets did the same, and they'd grown bolder with their brand-new submarine, eventually deciding to go for a dive in the Atlantic to test some of her innovative features. They knew the Atlantic was part of the American home turf, but the eager sailors did not care. Still, they were cautious and tried to avoid contact with any vessel within their radius, until they saw a juicy target they could trick off. This vessel happened to be the imposing aircraft carrier USS Saratoga of the United States Sixth Fleet. After patrolling the Mediterranean, the gigantic warship was bound for Miami, Florida. USS Saratoga was the second of 4 Forrestal-class supercarriers built for the United States Navy in the 1950s. She had a length of 324 meters, a beam of 40 meters, and a draft of 11 meters. Saratoga was powered by 4 Westinghouse geared turbines, 4 shafts, and 8 Babcock and Wilcox boilers, giving her a top speed of some 65 kilometers per hour. But that was not enough to outspeed the Golden Fish, and her crew was willing to prove it. K-162 decided to chase USS Saratoga to test her top speed and hiding capabilities. It was perilous and could lead to a full-fledged conflict, but the sailors were tired after a tedious patrol and wanted to relax and provoke the Americans. At first, K-162 approached USS Saratoga discreetly. However, the submarine quickly accelerated to reach the American vessel until the US sailors could finally spot her. Minutes later, the Pentagon received an alarming message from USS Saratoga. Many refused to believe it, while other intelligence personnel became highly nervous. Saratoga reported that an unidentified submarine had been following the warship for the past hours. She had failed to identify herself and was simply following Saratoga behind her tail. The American ship had attempted to break away, but the submarine insisted on following her under the water. During the alleged chase, the Golden Fish decided to go full speed at 80 kilometers per hour and went past the Saratoga before vanishing again. It was the first and last time an American and Soviet submarine got so close during the Cold War, and the US Navy was incredibly puzzled. The American sailors could not believe that a secret Soviet submarine had managed to bypass a powerful aircraft carrier. It was unprecedented for a submarine to travel that fast. USS Saratoga had been moving at full steam at more than 60 kilometers per hour, and she was still left behind. They didn't know there was a submarine in the world with such capabilities, but they were now face to face with K-162, the Golden Fish. In 1978, Soviet submarine K-162 was renamed K-222, but the Golden Fish nickname stuck. Although NATO forces knew very little about her, they had classified her as a Papa-class nuclear-powered cruise missile submarine. Still, despite the many innovations of the Golden Fish, her days were counted. As the years passed and new technology became available, K-222 stopped being an innovation and became a liability for the Soviet Navy. On September 30th, 1980, one of K-222's nuclear reactors was damaged during maintenance, limiting her operational capability. The Golden Fish was costly to maintain, and she drained more resources than a standard submarine. Hence, as the Soviet Union began to crumble, funds had to be cut. The revolutionary vessel was placed in reserve at the Belomorsk naval base in Severodvinsk and was then formally decommissioned from the Soviet Navy in 1988, after almost 20 years of service. She was then scrapped in March of 2010 and carefully dismantled with the nuclear reactors and fuel still on board. Still, even after her career came to an end, the legacy of the unique submarine lived on, with the Russian Alpha and Sierra-class submarines. The Soviet Zubr-class LCAC, or air-cushioned landing craft, is the world's largest hovercraft ever produced. Displacing over 555 tons and measuring more than 57 meters, the Zuber, or Promornik, is the ultimate amphibious vehicle used for disembarking and embarking troops, supplies, and vehicles. Thanks to its squared shape and unique pontoon structure, the Zuber can carry 500 heavily armed Russian Marines, 10 armored vehicles, or 3 battle tanks to swiftly deliver them to the battlefield. Developed in the 1980s by the Soviet Navy, the amphibious vehicle has been constantly modified to keep it updated with modern technologies. Today, less than a dozen such vessels have been produced, but the Russian Navy has ambitious plans to develop more and deploy them all the way to the Pacific and Eastern Europe. Soviet amphibious vehicles. As part of the Lend-Lease program signed by President Franklin Roosevelt on March 11, 1941, Ford and several other companies manufactured amphibious vehicles for the Soviet Union's fight against Germany. Ford even granted a license to manufacture amphibious vehicles such as the GPA Jeep, which would be crucial for future Soviet prototypes. When World War II ended, the USSR greatly expanded its domains over Europe and the Pacific under the iron grip of Joseph Stalin. And as hostilities toward the West increased, the Soviet armed forces began to consolidate their naval power and influence over China, Korea, and Vietnam. As part of this expansion, Soviet engineers began developing prototypes of amphibious vehicles that could be used against an upcoming conflict with the United States or some of its allies. The first of these vehicles was the GAZ-46, heavily inspired by forged GPA, and Warsaw Pact countries were employed to cross and conduct reconnaissance missions on rivers and lakes across Eastern Europe. The GAZ-46 was followed by the MAV, or Small Floating Vehicle. Although it could carry 5 men and some cargo, the Soviets wanted a bigger vehicle that could sustain a heavier load. Using the Allied DUKW as an inspiration, the USSR then introduced the BAV and the ZIS-485. This big floating vehicle could carry up to 2.5 tons of cargo, or 30 armed men ready for combat. The use of these varying amphibious vehicles led to the introduction of the PTS in 1965, a medium-sized amphibious transport that could carry twice the cargo of previous models. Additionally, the Soviet PTS could be operated in areas contaminated by chemical weapons or radiation. This vehicle and its capabilities would become the foundation of Project 1232.2, or the Pomornik-class amphibious landing craft, the world's largest transport of its type. The development of Project 1232.2 can be traced back to the mid-1970s, after the wars in Korea and Vietnam. The objective of this Soviet program was to develop an air-cushioned landing craft, a modern variation of an amphibious landing boat. Also known today as LCAC, the Soviet program took almost a decade of research before it came to life in the 1980s. The project was inspired by the versatility of the PTS amphibious vehicle and the Yasen-class assault hovercraft introduced by the Soviet Navy in 1965. By 1986, the first of these one-of-a-kind hovercraft had finally entered service in the Soviet Navy, and it was classified as the Zuber or Yasen-class LCAC. The new vehicle was produced by the Almaz shipbuilding company in what is known today as St. Petersburg. The Zubr-class LCAC was built for a series of specific purposes. It was meant to carry out rapid beach landings of troops, supplies, and vehicles on hostile enemy territory. Also, thanks to its colossal size and armament, the ship was to support the assaulting troops with direct fire from its own weapons. The Zuber hovercraft can weigh up to 555 tons if fully loaded, and has a length of 57 meters, a beam of 25.6 meters, and a draft of 1.6 meters. Its sturdy and seaworthy design with its square-shaped pontoon structure also provides the maximum amount of space for cargo storage. This cargo area has 400 square meters to carry either 500 fully armed Russian Marines, 10 armored fighting vehicles like the BMP-2 or BTR-70 with about 100 soldiers, or 3 main battle tanks like the T-80. Meanwhile, the pontoon superstructure is divided by 2 bulkheads and 3 distinct sections to facilitate cargo accommodation. What's more, the middle area was specifically designed to store the vehicles, as the compartment is fitted with taxi tracks and unloading ramps. The outer sections comprise the main and auxiliary power plants, the crew quarters, the garrison areas, and NBC protection systems for nuclear or chemical scenarios. In addition, the crew and troop sections feature heating and air conditioning systems, vibration isolation structures, and thermal and sound insulation coatings, making it the ultimate landing craft for use under different weather conditions. The Zuber hovercraft has airtight sealing in the compartments that can keep the crew and troops safe if threatened by weapons of mass destruction. This protection is also enhanced by providing each man with a gas mask and protective suit. The forward section of the Zuber has a raised bow and a lowering ramp for disembarking and embarking troops, vehicles, and supplies, with the hull designed to diminish the effect of naval mines, as it sits above an inflatable cushion bed that effectively protects the vehicle when it goes ashore. When the troops and supplies are going to be disembarked, the cushion is deflated to bring the bow ramp to ground level. The Zuber can land on shores that feature up to 5-degree gradients or vertical walls that are up to 1.6 meters tall. Additionally, the Zuber can operate over ice, land, and swamplands, as the hull is made of corrosion-resistant aluminum and magnesium alloy. Also, 3 large propulsion fans are located aft and form the backbone of the Zuber's propulsion system. Each one houses air propellers that provide the vessel with a top speed of up to 60 knots. 5 Kuznetsov Mk-12MB gasoline-fueled turboprop engines are used to power up all the Zuber's systems. 2 are used to generate lift, and 3 to propel the landing craft. With an approximate range of 300 miles and a fuel capacity of 56 tons, the Zuber has enough range and power to disembark and embark troops, cargo, and vehicles for quick amphibious operations. The Zuber is also equipped with 2 navigation radars, a magnetic compass, a radio direction finder, a satellite receiver, and other systems essentials for optional maritime operations to complement its amphibious nature. When it comes to armament and defensive systems, the ship is armed with a search radar, 4 Igla-1M air defense missile systems, and 2 rocket launchers. Finally, the boat is also equipped with an AO-18 6-barreled automatic gun that can also be used to attack ground and air targets. As far back as its introduction with the Soviet Navy in 1986, the Zubr-class LCAC has undergone several modifications to keep it up to date with current technologies. Today, only a handful of Zuber vessels are in service. 2 Zubr-class vessels serve with the Russian Navy, 2 with Ukraine, and 4 with the Greek Navy, while China plans to incorporate 4 of these landing crafts into its Navy, but they have not been delivered. The Russian vessels are named Mordovia and Evgeny Korchesov, while the ones in the Hellenic Navy are called Kefalonia, Ithaki, Kerkyra, and Zakynthos. In June of 2017, Russia announced it was going to restart the production of the Zubr-class LCAC, but none have been produced as of 2022. The Yasen-class submarines, a remarkable creation born from Soviet design bureaus in the late 1950s, are a mighty force on the high seas. With advanced design and technological prowess, they instill fear in the West, even in 2023. Despite facing initial financial and construction challenges, the Yasen-class has emerged as a symbol of Russian naval innovation. These submarines, exemplified by the lead unit Severodvinsk, are celebrated for their exceptional quietness, an attribute crucial for stealth operations. Equipped with an array of fearsome weaponry, including hypersonic missiles, their capabilities have captured the admiration of military observers. Moreover, the Yasen-M variant, characterized by heightened features and quicker construction times, adds a new dimension to Russia's submarine strategy. As they redefine maritime warfare dynamics, the Yasen-class submarines hold the promise of reshaping global naval power equations. In the late 1950s, 2 Soviet design bureaus, SKB-143 and TSKB-16, merged to form Malachit. Eventually, this bureau embarked on a project that would become a real contender in the 21st century military landscape, the Yasen-class submarines. Originally scheduled to begin in 1977 and finish in 1985, the construction of the first Yasen-class submarine didn't commence until December 21, 1993, due to financial issues. By 1996, work seemed to have stopped, and reports indicated less than 10% completion by 1999. Funding was restarted in 2003, with priority given to Borei-class nuclear ballistic missile submarines, or SSBNs, causing the lead Yasen-class unit, Severodvinsk, to be projected for readiness after 2010. The second submarine, Kazan, started in 2009, with plans for 1 multi-purpose submarine annually from 2011. An August 2009 U.S. Office of Naval Intelligence report praised Yasen-class submarines for their quietness compared to contemporary Russian and Chinese counterparts. Delays persisted, with the first submarine launch postponed in April 2010 and sea trials set for September 2011. The third submarine, Novosibirsk, was laid down in 2013. Severodvinsk was delivered to the Russian Navy in December 2013 and introduced in June 2014, earning praise from the U.S. Navy for its capabilities. During its maiden deployment in 2018, Severodvinsk reportedly remained undetected in the Atlantic Ocean for weeks. In spring 2020, rumors suggested Kazan and 5 other nuclear submarines were active in the northern Atlantic, with Kazan possibly undergoing sea trials. On October 4, 2021, Severodvinsk conducted successful test launches of the Zircon missile from surface and underwater positions. Despite initial setbacks, Yasen-class submarines have become advanced and elusive additions to the Russian Navy's fleet. The Yasen-class nuclear submarines are cutting-edge vessels renowned for their advanced design. A key part of the Russian fleet, they are equipped with an array of weaponry, including land attack cruise missiles, anti-ship missiles, and anti-submarine missiles like the P-800 Onika SLCM, Kaliber family SLCM, and 3M51 SLCM. Remarkably, there were plans shortly after their deployment to upgrade the fleet with hypersonic 3M22 Zircon cruise missiles. A distinctive feature is the inclusion of the AK-630 Irtish-M4 spherical sonar system, a first for Russian submarine classes. This sophisticated sonar comprises a spherical bow array, flank arrays, and a towed array, a technological addition that has prompted changes in the submarine's layout, as the torpedo tubes are now slanted to accommodate the larger sonar array. The submarines utilize a single-hull construction, differing from previous Russian submarines with double hulls. Crew sizes vary, ranging from 64 crew members to 85, suggesting a high degree of automation in the vessel's systems, in contrast to the U.S. Virginia-class submarines, which typically sail with a complement of 135 sailors. The Yasen-class submarines are powered by a fourth-generation nuclear reactor developed by Afrikantov OKBM, known for its longevity, with a projected 25 to 30-year core life and no need for refueling. The use of a new-generation reactor also contributes to reducing the vessel's noise level, a crucial factor in submarine warfare. One of the submarine's distinguishing characteristics is their exceptional quietness, a key advantage in submarine operations. According to Admiral Fogo, a U.S. Navy commander, these submarines are very quiet, making them highly effective in stealthy operations. Reports indicate that these submarines can operate at speeds of up to 20 knots, or even 28 knots, while remaining silent. The head of a prominent Russian shipbuilder has announced that efforts are in progress to outfit some of Russia's troublesome guided missile submarines with Zircon hypersonic weapons. Alexei Rachmaninoff, the general director of the United Shipbuilding Corporation, confirmed that the multi-purpose nuclear submarines of the Yasen-M project would be equipped with the Zircon missile system, following the successful deployment of the weapon on a Russian Navy frigate. The Yasen-class submarine, commissioned in 2013, are equipped with 10 torpedo tubes and 8 vertical launch system cells that can fire P-800 Onyx or 3M14 Kaliber missiles. The addition of the Zircon hypersonic missile is expected to enhance their threat level. Announced by Russian President Vladimir Putin in 2019, the Zircon is purportedly capable of reaching Mach 9 speeds and striking targets over 600 miles away. On the other hand, the Yasen-M subclass, an advanced version of the original Yasen-class, boasts improved features such as advanced quieting technology, sensors, and a quieter nuclear reactor. Top U.S. defense officials perceive these submarines as challenging due to their ability to deploy undetected within cruise missile range, posing a threat to critical infrastructure. In response to Russia's developments, the U.S. has been working on its own hypersonic weapon, the conventional prompt strike weapon, designed to counter such threats. The competition over hypersonic technology has intensified between the U.S., Russia, and China, as these missiles are difficult to intercept due to their high speeds, maneuverability, and unpredictable flight paths. As Russia and the U.S. race to deploy hypersonic weapons, these developments hold significant implications for global military dynamics. The incorporation of Zircon hypersonic missiles into Russia's Yasen-class submarines could amplify their capabilities, posing new challenges for defense strategies and potentially altering the balance of power in maritime conflicts. The launch of Russia's Yasen-M-class nuclear cruise missile submarine, the Kazan, offers insights into the nation's submarine fleet's future. Unlike its predecessor, Severodvinsk, Kazan has a shorter build time, indicating a potential trend for quicker construction and cost reduction in subsequent vessels. Both exhibit remarkable stealthiness, akin to top Western submarines, and possess a long-range strike capacity, even surpassing Western counterparts. According to the Royal United Services Institute, or RUSI, Kazan's quicker construction, just 8 years compared to Severodvinsk's longer time frame, indicates improvements in design efficiency and economic stability. Notably, it signals a shift towards nuclear-guided missile submarines from traditional hunter-killer roles. These SSGNs are designed for long-range strike missions instead of sea line of communication interdiction, altering NATO's anti-submarine warfare tactics. Kazan's reduced size, about 9 meters shorter than Severodvinsk, is attributed to factors like a smaller crew and a new generation KTP-6 monoblock reactor, contributing to improved quietness and evading detection. The shift towards a conformal array sonar, akin to Western designs, enhances her detection capabilities. The Yasen-M still retains its UKSK vertical launch system, carrying anti-ship and land attack missiles, including the hypersonic 3M22 Zircon missile, with immense speed and maneuverability. With all, the class presents challenges for Western defense. Their long-range strike capabilities negate the need to cross the Greenland-Iceland-UK gap, altering ASW strategies. NATO's defenses need adjustments against these threats, particularly since the Yasen and Yasen-M can eliminate surface vessels far from their location using satellite communications and precision firing. The Kazan highlights Russia's evolving approach to submarine warfare. The emphasis on versatile SSGNs reflects changing strategic priorities, favoring targeted damage and disruption in local conflicts over SLOC interdiction. Such a transformation requires NATO to rethink defense strategies against an increasingly versatile and capable Russian submarine threat in forward positions. As dawn breaks over the choppy waters of the Black Sea, the Russian Ivan Gren-class amphibious assault ship Pyotr Morganov slices through the waves, its crew on high alert. Tasked with securing maritime routes in the region, in the midst of the conflict with Ukraine, this vessel is armed with one of the world's fastest naval gun systems, the AK-630M2 Duet autocannon. Nicknamed by some the God of Fire, with its twin 30mm rotary cannons capable of unleashing a staggering 10,000 rounds per minute, the Duet stands ready to counter any threat, be it aerial, surface, or even small, fast-moving targets. Suddenly, Pyotr Morganov's radar detects an incoming anti-ship missile fired from a Ukrainian coastal battery. The crew springs into action as the AK-630M2 locks onto the missile, its advanced fire control system calculating trajectories with precision. The ship's captain gives the order, and in an instant, the sky is filled with the deafening roar of gunfire. The Duet's barrels rotate with a blur of motion, spewing a lethal stream of projectiles that cut through the dawn light like a swarm of locusts. The missile is targeted with pinpoint accuracy, exploding mid-air before raining harmless debris into the sea below. Designed to enhance the close-in weapon systems, or CIWS capabilities, of Russian naval vessels, the AK-630M2 Duet autocannon is the latest evolution of the AK-630, the original version of which was first developed by the Soviet Union in the 1960s as a defense mechanism against aerial threats like aircraft and missiles. The 630 designation comes from its 6-barrel rotary cannon, known for its high rate of fire and effectiveness in close-range engagements, and the 30mm rounds it uses. After extensive testing, the AK-630 was accepted into service in the 1970s and was widely deployed on various Soviet naval vessels, including corvettes, frigates, and larger ships. Operational experience over the years revealed limitations in the original AK-630, particularly in handling modern high-speed threats and multiple incoming targets simultaneously. To address these issues, the system was upgraded to the AK-630M in the late 1970s, which featured improved reliability and enhanced fire control capabilities for better accuracy and target engagement. In the early 1980s, a dual-barrel configuration was introduced, leading to the development of the AK-630M2 Roy. This new version mounted two 30mm rotary cannons, doubling the rate of fire to an unprecedented 10,000 rounds per minute. Although the Roy was successful in trials, it failed to go into production due to the emergence of systems like the 3M87 Cortic, later known as the Kashtan, which offered a more comprehensive defense solution by integrating both missile and gun capabilities. However, the Kashtan, while versatile, could not offer the extremely high rate of fire necessary to effectively engage and neutralize close-in, high-speed threats such as anti-ship missiles that could penetrate other defensive layers. Therefore, in the early 2000s, the concept of the dual-barrel system was revisited and enhanced, leading to the development and deployment of the AK-630M2 Duet. This system retained the high rate of fire of the Roy, but incorporated advanced firing control and targeting technologies capable of dealing more effectively with 21st century threats, as well as a new mount design. Measuring approximately 4.6 meters in length and weighing around 3,100 kilograms without ammunition, the AK-630M2 Duet employs two AO-18KD 30mm 6-barrel rotary cannons. This dual-barrel configuration allows for the same extremely high rate of fire as the Roy, proving considerably faster than most rival systems, such as the United States Phalanx CIWS, whose single 20mm M61 Vulcan Gatling gun can only manage between around 4,500 and 6,000 rounds a minute. Indeed, the only naval gun reported to have a higher rate of fire than the AK-630M2 Duet is the Chinese Type 1130 CIWS, featuring an 11-barrel rotary cannon that can reportedly manage up to 11,000 rounds a minute. The Duet's fire rate is crucial for creating a dense cloud of projectiles to intercept and destroy incoming threats at close range, especially high-speed anti-ship missiles, aircraft, and small surface targets. The system has a total ammunition capacity of 4,000 rounds and can use two different types of 30mm ammunition: high-explosive incendiary, or HEI rounds, which are designed to explode upon impact, causing significant damage through both blast and incendiary effects, and armor-piercing discarding SABO, or APDS rounds, which can penetrate armor using a high-velocity sub-caliber projectile that discards its outer casing upon leaving the barrel. This combination of ammunition types provides versatility in engaging different types of threats, as the HEI rounds are particularly effective against unarmored and lightly armored targets like aircraft, small boats, and incoming missiles, while the APDS rounds excel against opponents with stronger armor, such as heavier aircraft and small to medium-sized ships with reinforced hulls. Moreover, the AK-630M2 Duet is equipped with the MR-12302 fire control radar and the SP-521 electro-optical tracker, including thermal imaging and TV optical sights. The MR-12302 radar system allows the AK-630M2 to detect, track, and engage multiple targets simultaneously, enhancing the weapon's accuracy. This ensures that the AK-630M2 can effectively engage small, high-speed targets with precision. The ability to track multiple targets simultaneously also allows the system to defend against swarms of incoming threats, significantly boosting its defensive capabilities. Meanwhile, the SP-521 electro-optical tracker complements the radar system by providing visual tracking capabilities through thermal imaging and TV optical sights. The TV optical sights provide high-resolution visual tracking, allowing operators to manually verify and engage targets if necessary. This combination of thermal imaging and optical sights ensures that the system can accurately track and engage targets, even in challenging environmental conditions. Additionally, having both radar and optical tracking systems provides redundancy, ensuring continuous target engagement capability, even if one system is jammed or otherwise compromised. In addition, the AK-630M2 features a mount design that minimizes its radar cross-section, or RCS, making it less detectable by enemy radar systems. This reduced RCS enhances the overall stealth of the ship, improving its survivability by reducing the likelihood of the system being targeted and attacked by enemy forces. Enhanced stealth also allows the ship to operate closer to hostile environments without being easily detected, providing a tactical advantage. The first Duet prototype was completed in 2003, with trials beginning at Russian naval testing ranges the following year. The primary focus was on the performance of the dual 30mm rotary cannons, as the engineers assessed the rate of fire, the consistency of the ammunition feed, and the durability of the barrels under sustained firing conditions. They also checked the radar and electro-optical tracking system's ability to accurately track and engage a range of fast-moving targets, with tests conducted in various weather and lighting conditions to ensure effectiveness, as well as evaluating its integration with existing systems on board the test vessel. With testing complete by 2006, the design of the AK-630M2 was finalized, and production began at the JSC Tula machine building plant, around 120 miles south of Moscow. It was showcased in July 2007 at the Biennial International Maritime Defense Show in St. Petersburg. The first vessel to include the Duet in its arsenal was the landing ship Ivan Gren, launched in 2012, later joined by a second ship from the same class, Pyotr Morganov, launched in 2018. These have been designed to participate in amphibious assaults, meaning they are likely to be deployed in hotly contested environments close to shore. As they are a high-value target for enemy aircraft, helicopters, and fast attack craft, the Duet provides them with a crucial layer of defense against these threats with its high rate of fire and advanced targeting capabilities. Meanwhile, the 12 corvettes of the Buyan M-class are also fitted out with the autocannon, starting with Grad Svyatsk, launched in 2013, as well as the first two corvettes of the Karakurt class, launched in 2017. The addition of the Duet complements the corvette's existing armament, providing a balanced mix of offensive and defensive capabilities. This ensures they can conduct a wide range of operations, from missile strikes to maritime security missions, with robust self-defense. As yet, there have been no recorded instances of the AK-630M2 being used in a combat situation, but as Russia's war with neighboring Ukraine intensifies, there's a possibility that it may soon see some action, most likely in the strategically vital Black Sea. Elsewhere, nations including Russia vie for control over the Arctic region's shipping routes and vast natural resources. This has led it to be viewed as a potential hotspot for future naval conflict, in which the Duet may also have a part to play. Whatever happens, with its mind-blowing ability to spit out rounds at blistering speeds, it seems the AK-630M2 Duet will continue to provide crucial defense for the Russian Navy for some time yet.